Hey everyone, this is the K2 or Restaking Cloud walkthrough. So we're going to touch about a few details. What is a K2? What is a Restaking Cloud? How it works? What is the on-chain contract? What's the slashing logic? What's an SPP? What is a lot of technical terms, but also it's an overarching point that what is a K2, right? K2 means case card. Um, so take a step back. Restaking Cloud is an effort to bring how do you restake economic security, right? We start with the restaked ETH. So how do you bring economic security from the restaked ETH and extend the trust to other networks? And we're gonna talk about a bunch of utilities, what you can restake for. Um, Put it simply, you can restake your economic security for slashing, which means we have hundreds of rollups are going to come, or all the middlewares, or the oracles, or all the kind of things. They need economic security to decentralize or provide the services in a very transparent and verifiable manner for the market space. So what do you need? You need stake, right? You can borrow staked ETH from the pool, and then you can use it for other networks to secure them. They decentralized network. That's the one option if you think from a slashing perspective. But restaking is not just limited to slashing. Restaking is reusing the economic security and trust. So essentially looking at that is a 200 billion asset class. And if you stake about 70% or 80%. And we want to make sure the sovereign asset as an ETH will be available for other protocols and other networks to be a base layer to build upon their decentralized network or reinforce the service quality, operations, and things like that. But how do you do this? What's just the money will do it? No. So you need to have a verification mechanism that outside networks, if they are borrowing this capital, if they are reinforcing their operations, if they're reinforcing their decentralized stack, there's a mechanism the slashing will happen or payouts will happen. So this is a very important subject. Someone will tell something is going right or wrong, and they get paid for that. That's the nutshell, right? And that need to be verified. And if it is an open market, then you can have all kind of problems like, how do you know the guy is telling the truth? So the truthfulness and verifiability is a very important part. And along with that comes with the report integrity, right? So the K2 leverage a zero knowledge scheme that allow anyone can inject a slashing logic. Anyone can inject a reporting logic for the oracles are price are good. If there's any services going down, then they can tell that. Or if you're, whatever that's the cross-chain mechanism is that you're doing is correct. So this is like the payouts, or it could be slashing. I don't want to confuse a lot, but just let's stick to the slashing logic. If you say that if a rollup is going, if there is an effort proof and things like that, you can slash it. But this is actually a good thing for the user base and the decentralized network because there's nobody you can go and ask like the money to come back. The decentralized network is more of like reporting and fault tolerance, in Ethereum. If something happens in Ethereum, you cannot go to somewhere and say that, I need to get my ETH. But rather, you want to make sure the chain is not reorged. You want to make sure the blocks are not corrupted, not tampered, not just synced. So similarly, the toolings that you're getting, the data is not corrupted. So all this kind of stuff, right? So from a decentralized standpoint, any slashing mechanism is positive for the users. It's not a negative thing, but you're just making sure the networks are correct. But if you take a step back and see that economic security is kind of um, a fallback mechanism that you can build any kind of logic on top. It's not only about slashing the network liveness or fault tolerance and things like that, but you can inject this economic security available for your own protocol and say that, hey, we're doing this kind of liquidation mechanisms are correct, and this we watch out for. So there will be a watcher network that there's put it simply as a task robots. You can tell them anything that you want to do by them, and they will inject this data. One important factor is the reporter mechanism. The reporter is a witness endorsement scheme by the ZK gadget. And this is what it is making possible, and external data is injected to on-chain contract with integrity. What does that mean? No one can change the data in between the last man flip problem. Or there's a absolute integrity on the data. It's proved by zero knowledge scheme, and there's a designated verifier. We're going to walk through some of this stuff. We're going to show some of the UI, how this thing happens. It's very simple. If you want to use K2, just go and deposit. If you have staked ETH, then you get a yield on top of your staked ETH yield, right? That's pretty simple. So who can deposit? Anyone who has an LST or RETH, DETH, or any LSTs that has been provisioned can actually deposit that one, right? So it's very inclusive. The middlewares just go and open and say, hey, I want X amount of security, and they open that called SBP. That's a slashable borrow position, or secure borrow position. Which, if you want $1 million worth of security, you don't really pay that $1 million, but you just pay usage fee for that. But you can enjoy that $1 million security throughout the year. And now all this pooled ETH is available for you to reinforce, protect, and extend the trust for you. And again, this is like a click of a button that you have it. That's it. The slashing logic or proving logic, or you want to verify your data, is all you can tell the reporter, and then they will just watch out for you, and the designated verifier do it. It's pretty simple, very go-to solution, like a very mainstream DeFi kind of stuff. One thing important for the K2, unlike any other slashing logic, everyone say, how does the slashing or reporting works is, if you have a private data, it need to make it public. And that's more or less you make your data doxing, right? There is no such thing here. This is a private, publicly validate your private data without revealing it. So at no point that your data will become doxed in this process. But however, if you're taking a data from public blockchain, it is already public, right? You can go and get that information from that Ethereum blockchain information. You don't really have a privacy. However, the ZK gadget will not reveal that data immediately to a designated provider. So it's still private within that sense. So if you're using the K2 as a reporter for your private data repository, it's always been private. So your data will never get doxed in between, or someone can actually spoof it. So this is one of the most important part, is like it remain private within the mechanism, and it's also tamper proof. So K2 is by default comply with the privacy aware property. So you can actually use this scheme to reinforce your Web2 or service schemes or protocols or any kind of things that you want to. And that's the beauty of it. This is the first time a coordination is coming together, a public and private composability. The data composability, you can build any kind of logic. For example, if you're building any kind of lending protocol, you want to know some credit score for somewhere, but you don't want to know, the person who don't want to disclose all the information to the other party, the reporter, you can just use the service to hire a reporter to do that. It will never reveal the information, but it will just verify the needed information from the private data source, right? So it's kind of a disclosures are also possible. So K2 is a platform. You can build additional logic, anything that you want to as a periphery. It's a very simple protocol, a restaking layer. Making it available, the decentralized innovation is finally can go at 200 mile speed, or, put it simple, a commercial department says that Mach 3, so it's not 200 mile, it's just like much faster than that. But it's important that it can go along with private data repositories useful for public blockchain actions. And that's something that makes me always excited. All right, so let's get to it.
I don't know if you or like Derek can maybe so you talked about utilizing restaked ETH. Like, how are we defining restaked ETH? Can I directly use my ETH or RETH in K2, or how is it working, and how do we understand the different risks associated with all the different assets in the context of like economic security? Does an RETH and an SDETH have the same economic security here, like in the K2 platform? I don't know if you guys can help with that.
Right. So the question, if I understood correctly, it's more related to what are you going to do if your asset, that's the K2 accepted assets, are ETH or not, right? If you have an STETH, if you have RETH, if you have other kind of ETH, how do you ensure that the underlying asset is being paid out to the reporters or to the people who are saying that they want to get the service?
Yeah,
Yeah.
yeah.
So
Do I have
it's
to pick as a reporter if I'm slashing? Do I pick what STETH I receive, or?
No, you actually, what you do is like there's a unified mechanism. So currently K2 only accept staked ETH, right? So that's the base asset. And it can be represented in many forms like STETH or RETH or DETH, but end of the day, the user will get ETH. That's more important. So there's a in between a unified protocol called KETH. What it will do is like it will take all this kind of LSTs, make sure it will hold liable for the redeemability part, and redemption is on ETH. So anyone who is basically getting KETH can redeem ETH for KETH, right? So regardless of any kind of representation token, so if you're not aware about liquid staking in Ethereum, all the staked ETH are not represented coming back as a ETH. It's been in the DeFi. There's a representation tokens for the liquid staking tokens called STETH 20 billion out there, RE for Rocket Pool, and there's like a few number of other kind of LSDs, and then there's LSD networks like Stakehouse. DETH is there, which is properly redeemable for 1:1 ETH. So what happens? You cannot have multiple risk profile for the payouts. You want to receive ETH for that, right? So you always want to receive that ETH. That's the most advantageous asset that you want to have it doing some work. You're hiring reporters to do something, and middlewares are hiring reporters to tell the world that they are doing great and their systems are working great. The K2 pools are telling the reporters, hey, you tell us if there's something happening with our capital at stake. We're getting yield, but we pay them, but only for things that has happened. So essentially the unit of economics here is ETH in K2 to begin with, KETH. There's nothing stopping to have other kind of collateral, but we love ETH because it's ultrasound money. So KETH enable to add any kind of LSDs out there into the mix. That makes sense, but end of the day, you get ETH. That's the beauty of it.
So just to kind of clarify and make sure there's some sort of understanding here. You know, the lending and the borrowing and the payouts, it sounds like are all done in ETH. People can inject their third-party tokens within here, but it doesn't mean that people will necessarily receive rewards in these third-party tokens. If they're lending ETH, they receive ETH for when people
Yeah,
borrow it. Yeah.
yeah, they always receive ETH. It's always ETH, but it's anyone can participate in the system. So if you're a LSD token holder, you're incentivized to get more yield, and if you don't want more yield than ETH, fine, it's okay. But if you want more yield from on top of your staking yield that you're receiving from Ethereum, you can come here, and then you can help others to source that ETH security, and you can help them to grow, and you get a piece of that.
How are you helping others? Like, what are you doing? Like, and who is doing what? Sorry, are you talking about proposers here, or?
No, no. So any LSD token holder can deposit their tokens, right? And you go to the DApp, and if you have STE, then it will show select STE, then you deposit. You have your just like any kind of you're providing lending position in Aave compound, you just deposit, and you have this kind of X amount of tokens have been received, and you get your staking yield plus whatever the yield that is being given by the K2. So let's say you have 3.5% for the staking ETH, but then you get another nice 5% is the K2 is giving for all the pool depositors. It can be 15%, it can be 20%, depends on how many middlewares are sourcing this. So middlewares are paying this usage fee, which is the yield that is going to the K2 depositors. Make sense?
Yeah, right. Okay.
You can take it as a first lending pool for Ethereum security for all the blockchains.
So you're using the term slashing a lot, and I kind of understand that whole idea, if you're working particularly with, ensuring credibility of data or something with like, there's a node or an oracle and you want to permissionlessly onboard them and say you're able to, make sure they have the correct liveness and sending the correct information, and it kind of can make that process permissionless. But would you say that the term slashing is kind of blanket to everything that can be done here?
No, not necessarily. So the slashing, quote unquote, slashing is a very, very, non word for everyone, just like, what's a slashing? What is a slashing? Slashing means someone is telling you something relevant to a network, and they get paid for that. So it's a truth teller, right? But you need to verify what they're saying is actually relevant and it's qualified. Somebody has done something deviated from the logic, right? So here, the slashing is one utility. You can actually use this security and say that the reporters will tell you, oh, I want only know if there is any kind of deviation from a standard procedure, and want to have a whole liable for that one. That's a slashing. So you can say that payout could be marked as a slashing. But if you say that, if something happens, if I want to give a payout for how do I say, if anything happened, X and Y payout has to be done. And that's just a simple payout. And it could be order of magnitude higher. Like, if there is a cross-in message just didn't went through, and then it has to be like 10,000, and 10,000 has been paid. But you need to tell the logic. Currently, it's a very simple logic what the K2 has. What kind of SVP that he can borrow? There are two kind of events, which is one is a soft.
What is an SVP? Did we define SVP?
It's a slashable borrow position or securing borrow position. You can call that one. S stand for slashing or security, right? So not the security in terms of security, but a secure, just to be very clear. That's not security in any way. Right? We're not doing that. So the secure borrow position. Yeah.
You take tokens like a borrowing protocol, like.
Oh, that's a good question. So you don't give any kind of collateral. So the secure borrow position, you can take it like you getting this kind of a the K ETH for your business logic for collateral free. You only pay a small fee. That's called the secure borrowing position or slashable borrowing position, and then it will offer that kind of there is a threshold for what kind of payouts it's dispensed per time per event, right? Currently there are rules around like per event is half a ETH or 5 ETH, and you can tell which is the gravity of the things that you want to, and based on your events, the usage fee is calculated, and based on how much security is available for you to lease from the pool. So this all automatically happens on the smart contract. You don't really have to worry. You say, hey, I will have 5 different categories, and 3 of them I want every time it happens, you need to pay 0.2 ETH. Another one, 3, if it only happens very, very rarely, but every time it happens, you should pay 3 ETH per event, right? And it can happen anytime, in any number of times. Fine, and it automatically calculates the usage fee for that and how much you want in a secured. I want to have $1 million worth of ETH, right? So it just give you, looking at the pool, looking at your business logic per event, it gives you a usage fee, and that's the only thing that you're paying, and you get 1 year full protection, and you can terminate anytime. That's very important. So it has all the kind of DeFi capabilities. 24/7, you can terminate it, you can cancel it. If the pool goes down, it will automatically readjust the positions. Now, in the future, we can have separate logics built around this kind of pooling. Rather than just only two slab items, you can actually have like a preferred pool giving a preferred security. Like per event, you can actually have 100 ETH per event, and which may require some sort of additional checkpoints. I don't know, but that could happen. But that's something that can do in down the line. But at the moment, it's very like off the shelf. We want to onboard as many people to run infrastructure. We want to have like more info and smart contracts to ensure their protocols are working. Extend the confidence, extend the trust to the end user, extend the trust to the integrators, extend the trust to your customers, extend the security to your application built on your infrastructure layer, and accelerate your development faster with fraction of capital you need. So you don't really have to go out and raise millions of dollars. Rather, just get the security, launch your decentralized network, figure it out. Next time maybe you will have your own token. You want to have much more, better security, and you can figure that out. So we are really helping everyone to do all kind of innovations.
It sounds like there's really kind of no limit to how this can be used. It's really up to however people want to do it. And there's some like kind of clear-cut use cases in current DeFi, but it'll likely unlock a bunch of new use cases, within 3 to 6 months when people actually see what's possible and start to build around these contracts.
Yeah, and you can use it in conjunction with the private or public source because it's the whole process private. The data integrity is maintained because it's ZK, so you can actually plug in. It will never leak any kind of information between this point. All right.
Might be worth going into the technical details, maybe just to explore some more aspects of the platform. It is very much parameterized to the application's needs here. So that makes it quite flexible, really.
Right.
Maybe what we can do is talk about how we can facilitate the reporting and slashing that you were talking about, and link into the contracts themselves. We can have Phil do that. So what I'll do is I'll give let me host. Can I please have screen sharing? But whilst I'm getting screen sharing permissions, what we give is a middleware package. Is it good now? Yeah, cool. Yeah. So the reporting element here is a package that can be Dockerized. It can be hosted in any way you want. We call it a middleware. So what Phil's going to do is, when we talk about the contracts, is we'll get into the core of this K2 K-squared lending platform. And what I'm going to focus on here is the reporting. So these reporters are working for your network and are keeping the entities that are supposed to be running the software accountable, because at the end of the day, you have this stream of, you can see on the right, you've got the stream of staked ETH being sent to lenders of the platform in exchange for doing something. So this is just a continuous stream between a defined period. And if at any point there are problems with your application as a service provider, if there are issues with your network, a reporter can look for those issues, scan for them, report them, and get and present it to the contract in order to get a payout. Service providers as well can run their own reporters in order to limit the in order to limit the any issues that you might cause in the protocol. But if there is there are certain rules around that defined in the contract around, there is a line between software being faulty, leading to a slashing, and obviously genuine events around what we call liveness and corruption. So if we go into a bit more detail about that reporting element here, you might get a bit of a picture, and you might get some insight into what Matt was talking about regarding how we can leverage public-private data in that sense. So what we have here is so this is the structure on how it's working. The SLA middleware, the middleware software is given to you as a package that you can just run out of the box. That allows you to be compatible with the K2 contracts, and it is a standardized interface for the reporters. This is sort of the beacon that you provide for your network and your software as a service provider. So when you create the SLA agreement between the economic security and yourself, you're going to run the middleware, and the reporters will have access to that in order to report slash into the contract. Obviously, if you don't run the middleware, you run the risk of basically, the interest payment that you pay for upfront borrowing the economic security. You run the risk, if you don't run a middleware reporter, just giving the money away for free for people that potentially aren't even running your software. So it's in your interest to actually run this. So the way it is structured here. So I'll get into what is an RPBS reporter.
Wait. So you touched a good point. So if you're borrowing money, make sure that how you want to reuse that security, right? What do you want the reporters to watch out for? You want to watch out for something goes down in your system, or you want to make sure that your operational compliance is, like you go to if you open status.apple.com or status.blockswap.com, like you have this kind of status machine, and it shows like everything is running correct. And if you want to ensure your customers that everything is okay, that's the confidence. Or if you want to add additional logic, just make sure you're getting this economic trust and security. Just tell the reporters what they want to watch out for. And K2 is giving you all the security, right? So if you don't use it, then it just it's
you're
like
just
a subscription.
Giving money away for free. Yeah.
Yeah, it's a subscription.
Yeah.
Like you made everyone just make like in a new year, I'm going to get the gym, and then you just take the subscription. You never hit the gym, and you don't get anything. Right? So if you hit the gym, and you look good.
Yeah, but you might still be paying for the membership each month, right? But not actually benefiting from it. I get the point. Yeah. Cool. But so the middleware tooling. So what you're providing as a service provider, so what you're providing as a service provider is there's various APIs that you need to inject into the middleware. So the middleware, like I said, is it's got a standard structure and acts as that interface, right? You need to plug in the APIs that the middleware will use in order to verify the authenticity of a report coming from a reporter.
Or they can put someone else. The designator, like if you want to have like some ZK validator to do that, do it, but designator verified. So you can act yourself, or you can just use another party.
Yeah, actually, that's a good way of putting it. Yeah, the SLA middleware is a designated verifier, and when you open your SPP, you nominate the designated verifier. So you either run it yourself, or you get like a known or trusted node runner, or however you want to do it. When you open the position, you are nominating that designated verifier.
Or if your smart contract is deviating from its logic, right? Mm-hmm. So if you have an added proxy and things like that, say some liquidation logic is just completely gone wobbly, like you don't want to have that. That alert can be, you can just say if you have an oracle from somewhere, like, oh, if there is any deviation from this, or am I going like more than 3% of the threshold, then it's get liquidated. Boom, it will get reported. So you can designate a verifier, could be anyone. It could be yourself. It could be, you could basically for that particular purpose, for that particular event reporting, you can say that this is the designated verifier.
Mm. It's a good point, actually. It is a good point because we define, broadly speaking, we define two main types of events
Yeah,
in the middleware. We define issues with liveness, so liveness events, and we define corruption events.
yeah.
So liveness is to do with obviously users not who are supposed to be running the software. They are not actually the software is offline. And there are many metrics that you can use to define liveness, but liveness, the source of liveness it's down to your application. It can be an on-chain source, it can be an off-chain, it could be a mix of the two, right? You plug it into the middle. Right? Same
Yeah,
with the corruption. Yeah.
yeah. So remember that there was an instance that a lot of there's many instances, not one instance, or many instances. A lot of people actually use some of the DEX as a protocol, and then the volume weighted average just goes up and down or tap or something like that. There are like few times the DeFi protocols actually got compromised because someone manipulated the oracle because they're using this kind of a Uniswap pool or other pool for Oracle, and then integrate it. Even the compound has an instance when the DAI just like slip through thing, and then they use the Coinbase that was off, but then it just made some of the liquidation happens. You can have, if you're using a spectrum of oracles, if one thing actually off, and immediately report and just pause the contract. So you can take the based on the event, if it has been getting reported, you can just simply write a logic and it just pauses your things immediately, and then the governance can take care of it later. And this comes very handy when the derivatives trading, the DeFi protocols, lending and borrowing. If something happens at somewhere, you can prevent this kind of chain reaction is getting injected, contaminate, or you can just literally stop the contagion to your protocol. So now you have someone who's incentivized to watch out for the things. Only you got to see that these are the things. These are the designated verifier. If it is off, let us know. So it's useful in many ways because now you have someone who's paying for that, and that's the incentivized coordination, reporting, slashing and verifying.
You can have reporters working all across the world, like in different time zones, right? Keeping an eye on your protocol, obviously, because it's if you're an on-chain protocol, your protocol is deployed on a public blockchain like Ethereum, which is working 24 hours a day, right? Maybe you have a small team behind your protocol. You don't have the ability to look after your protocol 24 hours a day, because it's physically, humanly not possible. But across different time zones, you can hire reporters for your platform to do that kind of work and to limit the contagion, right? So you're paying not to lose too much, right? So you're limiting the contagion, as you said.
Yeah, always, or maybe like even in staking, if you detect some sort of slashing, you have already bots. Just immediately report, and any other validity associated with that node need to be stopped immediately, right? So
yeah,
you can. There are a lot of things you can do. It's more programmable now. The data reporting is programmable. You can actually do any kind of off-chain data. You can program it, and that makes it super useful. And a large pool of deposits, ETH deposits, is readily available for you to lease it at a fraction of cost.
Right. I think that's a really good way of putting it. So as a service provider, once you've injected the liveness source, corruption source, and this final one is unique report identification. So multiple reporters may detect the same event, and you need a unique way of ensuring that same event is not reported twice. So, you might say that you can only report like liveness issue. You might be able to report like liveness once every X period, right? So if there are, for example, two validators offline or two software runners offline, you might be able to report that every every 10 minutes or otherwise you would just report, and it would just get a bit crazy. So you need some way of uniquely identifying the event that has taken place. And again, you can inject that source can be an on-chain source, so it can be an on-chain nonce, or you can generate that independently off-chain. But you plug that in. So basically, the reporter will come to the middleware and say, "Hey, I detected either a liveness event and a corruption event. Here is the unique, here is the event details." And it can basically say, yeah, that is definitely an issue, but they're all going to be sort of categorized in the same way under the same unique report identifier. And so what that means is that it just means that the same event cannot be reported more than once to the smart contracts. So that takes care of the middleware. The middleware in blue that's given to you out of the box. And you just plug in all of these other subjective rules. So the middleware only deals with objective information. It takes information given by a reporter and goes to your liveness or your corruption API, and it says, "Is this true? Can you see this as well?" And if it says, "Yeah," then you go ahead and you authorize slashing, and the reporter will be able to walk away and submit that to the contract and get a payout for that, right? That's that's what they're working for. So, on the reporting side of things, what we were talking about earlier is about how you can avoid the last man flip problem. So, this is to say that if I'm a reporter and I come and present to a middleware a liveness or a corruption event that's been detected in the network, I know that if I reveal this data either partially or fully, or depending on the application and the use case, that once I hand over the information, that it's not going to be tampered with. The only thing that they can do is verify, sign, and allow you to go ahead to the smart contracts. So that is through the use of RPBS ZK self-attestation. So reporter looks out and scans for issues in the network and does a self-attestation on the data, muting it and producing a signature that has unforgeability properties. And that information can be presented to the middleware. Now we have the data can be revealed partially, so you can give some of the information for verification, and the information, some of the information can be blinded and private, and it's much more than just a simple hash of the data. So it's an entire protocol here with ZK-like properties. So so as you can see here, you're looking out for liveness and corruption events. You're storing them and presenting them to the middleware. You will get a signed report back. Report that to the smart contract, which will slash the SPP position, and the reporter will get ETH, or a unit of ETH that they can unwrap for underlying ETH. So that gives a high-level overview of what is taking place. I can show you. So we have, I have a middleware that I'm running. I have like an identifier API and a liveness API because I'm going to show like a liveness event. And then, for example, we have here's an example of. So this is the ZK proof using RPVS of a liveness event that was detected. This is just for illustrative purposes. This is, pre-alpha, so the software is being wrapped up. So some things might change from this walkthrough, but the idea here is that you're at a high level. You're specifying the event type, and you specify event data. So basically, in this case, we've detected, you can see here the public information that has been revealed for verification is the number of validators that are online, number of validators that are offline, and how many are there in total. And we can have, against the liveness API, we can verify this information. So if we run this, in this case, the reporter is saying, I've detected this, and this means based on how you've configured your /full borrow position. So when you open the position, as we said before, you're specifying a number of parameters that Phil will go through when he goes through the contract, but you're specifying what the designated verifier is that can authorize slashing. And you specify how much ETH can you slash per liveness event, how much ETH can you slash per corruption event. There is a min and max range for those things. So and how much KETH that you pay in interest to the lenders for utilizing the economic security is based on the risky profile of your SPP. So the higher the
so in a sense, this is an infrastructure layer for sourcing security and then reporting that economic security and reporting what are the things happens outside of the chain, right? So the reporter can take information and then they're using the ZK. What is a ZK? You're showing a lot of Z1 hat and A2 hat. Do they really need to know the circuit and everything, or it's just like very easy to do it because
no,
it's a ZK report?
So there's a package that comes with the appropriate abstraction layers, so that you don't have to worry about. You just supply. You basically say what information you want to be public, what information you want to be blinded, and you want to perform a self-attestation. So that mutes the data. So all of these are points. The Z1 hat, C1 hat. They're just the points on a curve. So that is using the protocol itself. But what that is doing is that it is ensuring that the integrity of the data being verified is not tampered when it is presented to the for verification.
This is kind of a reporting co-processor. This gadget is a reporting co-processor every single time.
Right.
Something like that. Yeah.
Yeah.
Because normally when you talk about ZK, it just like comes. People think about, oh, do I need to do like XYZ? I don't know anything about zero knowledge scheme. But here, things has been done in such a way that anyone can integrate freely and easily without knowing much about underlying ZK tech, because it has been done in a gadget way. So it's it's given in a very standard package. So just inject into your logic, just like you do into our API endpoint.
Yeah, precisely. And there is so we have you can the verification can be done in JavaScript, Golang, Solidity. We have all kinds of verification modules that have been audited and tested already. So, but it's packaged, like you said, in such a way in a gadget fashion so that people can just take it off the shelf and just they're focusing on their data that they're testing and that they need verifying. And then, like we see in this, so something has been reported, it was verified, and so we get a signed report. We can take this now to a smart contract. So we have who's going to be slashed, the block when this was detected. This is the signature, this self-attestation signature that was generated. How much is going to be slashed, and by when the deadline is that it needs to be submitted to the contracts. And we have here this is even a lower level of abstraction than the user will see. The user will just have they will have access to an SDK. So you'll just be able to go to PON SDK. You will select this, and then you will spin up an installation of the SDK. And you will simply access the reporter registry. You will have the violation verified, and you can report this to the smart contract. So basically, it's put in a format that is actually easy to get verified as fast as possible and submitted into the smart contract in an easy to use fashion. Well, it'll be like the PON SDK here. So it's not exactly the same SDK, but it will be like this. You get the violations verified, and you can report it. Yeah, and that will interact with the middlewares like this. We can have I think it might be nice for Phil to go through the contracts at this point.
Yeah.
Okay, let me share my screen. Can you see my screen? The diagram?
Yeah.
Yeah, so this is the Cascade, lending smart contract architecture. So as mentioned earlier, um yeah, we have this core Cascade lending smart contract, and also we have some contracts like the report the registry and Cascade lending deposit contract. But the main contract is this Cascade lending contract. So what is this Cascade lending contract? It is the contract that accept um pays liquidity from the LSD owners, which is called as a lenders, and allow the borrowers to borrow, create any selectable economic security position by paying upfront. So we have a rule here. So the borrowers need to pay upfront to create a debt position. And also a borrower can have only one position at any point. So that's why we have create debt position and another function like increase debt position when they want to increase their position in while they have already created a debt position, something like that. And also we have the reporter logic here. So reporters can join the reporter registry and submit their report, and we verify the reporter signature using the designated verifier as mentioned earlier. And also we accept the slash amount report in the Cascade lending contract, and we have kind of two kind of slash type. For one is for liveness and one is for corruption. So we have the slash logic, and based on the slash amounts, we have some liquidation logic as well. Yeah. This is and also regarding this Cascade lending deposit contract. So actually this Cascade lending contract is designed to accept only Ks. So we introduced a separate Cascade lending deposit contract that allow any LSD owners can join. Let's say a user has STs and he deposits, he wants to lend his LSD token to this scaled lending. So the Cascade lending smart contract. In this case, he can deposit STs into this deposit contract, and this deposit contract will deposit his LSD to KEs and mint KEs, and deposit that case back to this Cascade lending contract and create a liquidity position for the lenders. Yeah, that's why we need a separate deposit contract. Yeah, so I think that's it in the overview of the scaled smart contract architecture level. So, so we already have those smart contracts implemented. So this is the Cascade lending smart contract, which is the main core smart contract for K2. So what I want to talk about is the um, the borrow duration. So a borrower can create any security position, but we only support a fixed borrow position for now. But we can design that later to support any kind of borrow durations, like but it is only designed to support fixed duration.
You can, but you can terminate early, right? That's the
yeah.
Okay.
We have that logic as well. So let me explain the functions one by one. So we have deposit function. So it is to allow LSD owners to deposit his KEs into this smart contract and create his liquidity position. We call this liquidity as original liquidity in the smart contract level. So when they deposit, we transfer the KEs from the user's wallet, and we increase the original liquidity and mint this K2 share token to the user. So I forgot to say that this Cascade lending smart contract is ESD20 token itself. It means that user can transfer this K2 share token to anyone. That means he can transfer the liquidity to any address if they want. Yeah. It is transferable token.
And yeah, we have withdraw function, which is the opposite of liquid. Sorry, deposit. So the lender can withdraw his case from the smart contract if they want. And we have claim function. So as you can see in this diagram, the LSD owners lend keys, and they can own some interest from the borrowers. So the borrowers paid upfront, and that upfront is distributed to the lenders based on their shares. Yeah, so we have the claim function to allow lenders to claim keys. That's the function. And also we have this slash function. This is called from the reporter registry. And as mentioned earlier, we have the slash type, and the slash type is one of liveness and corruptions. And yeah, and the slash amount can't exceed the max slashable amount set for liveness and corruption. So let me explain about this max slashable amount later when I explain this interest rate model. Sorry, in the borrow function. And also when the slash happens, we check the user's debt position. So we need to check the outstanding interest, and if the outstanding interest is not enough, then we liquidate the debtor's position. Yeah, and the outstanding interest is distributed to lenders if the liquidation happens. Yeah, here we have the terminate function. This is to allow user to terminate his debt position if the current liquidity is not enough. So in that case, he will pay some penalty, but he will, half of the penalties go to lenders and half of the penalty goes to debtors. And also, yeah, we have a separate liquid function that checks the current outstanding interest, and if the outstanding interest is not enough, then liquidate the debtor's position. Yeah, anyone can call this liquidate function. And also, we have top-up slash amount function, which is for the borrowers. So when the slash happens, we record the slash amount for the debtor position, and a borrower can top up his slash amount by paying extra keys to the smart contract. Yeah. Yeah, and also we have the main function, this borrow function. So it is allowed borrowers to create a debt position, and this is only called when the user doesn't have any debt position. Yeah. And yeah, we also have the increase debt function, which is called when a user has already existing debt position. So he can increase the borrow amount, he can increase the backslash amount, or he can reset the duration, something like that. There is a couple of options for users to choose. And yeah, in the borrow function, okay, so let me explain about the interest rate model. So as I mentioned earlier, when a user creates a debt position, he needs to pay upfront interest. So how this upfront interest is calculated? So it's calculated from the interest rate model, which is set for this Cascade lending smart contract. So this interest rate model calculates the interest based on the current liquidity, and this means how much the LSD owners deposited, and also we need to check the borrowed liquidity, which means how much liquidity the borrowers borrowed from the K2. And also there is some additional parameters like max slashable amount for liveness and max slashable amount for corruptions. So there is some range. So this max slashable amount for liveness is in range of 0 to 1. And for corruptions, it's in range of 0 to 5 is. And yeah, we calculate the interest rate based on the original liquidity and borrowed liquidity. And as you can see, if the borrowed liquidity increased, then the interest rate is increased. And if it's past the break points, then it will increase. It will be increased rapidly. Yeah. And user needs to pay some additional, interest for more max-legible amount and for liveness and corruption.
But that is a reflection on the risk of the borrower position, right?
Yeah. If a user wants to create a position with more max-legible amount, range, then he needs, pay more interest.
Got it. Thanks.
Yeah, that's the interest upfront interest model on borrow and increase that function. And yeah, and also we have some couple of query functions and I think I need to explain about this max borrowable amounts. So this is the function that returns the expected max borrow amount using the provided interest amount. So let's say a user has 10 Ks and he wants to borrow a create a debt position. And in that case, he can calculate how much he can borrow from this Cascade lending contract. So yeah, this function is used from front to calculate, to show how much a user can borrow using his, case balance, something like that. And that's it on the Cascade lending side. And also we have Cascade lending depositor contract. As mentioned, it's really easy. So we have deposit function and it accepts any tokens supported on KETH. So if the provided token is not KETH, we need to deposit this underlying token to KETH vault, and this will mint the KETH, and we transfer the KETH back to, the deposit this KETH to Cascade lending contract. And also we have reporter registry. So we have the slash type defined here, and we have some report structure. And yeah, there is a register reporter function. So this is the function to register a reporter to this reporter registry. And yeah, we have submit report function. We have the batch submit reports as well to support, multiple, submit to able to submit multiple reports in one transaction. And in the submit transaction function, so yeah, we need to check if the report is valid with the report signature. So and if the report is valid, we call this slash function of Cascade lending contract. So we already explained about slash function there. And about this valid report check, so we check if the report is signed by the designated verifier, which is set by the debtor. So if we check the borrow function, if we check the borrow function, the first parameter is the designated verifier. So this means that the borrower will set the designated verifier when they create a debt position. So we use this designated verifier to verify the report signature. Yeah, and that's how the valid report check works. Yeah, I think that's it on the report registry. So yeah, I think that explains the main workflow of the smart contract.
So,
if you have any questions.
yeah, anyone has a question? So this is currently like the ETH pool is staked ETH is the only accepted token, right? For the K2.
Yeah.
And the representation tokens will just go through the KETH and it will just make sure the one thing in the KETH is allowing them to redeem ETH, right? That's why you're basically having KETH here. When you receive KETH, you can redeem it for ETH, right? That's the whole point
Yeah.
of accepting any kind of representation tokens, but the KETH will dispense ETH 1:1, whatever the KETH that it has. So that's the
Yeah, right.
unified risk profile. Okay. Because it's not a different token. It's just abstraction of multiple risk and multiple rates into one target rate. So it will help people who are reporting, who are providing ETH here, who are borrowing. Everyone have like a unified rate, right? For calculation.
Yeah.
So when people, they're coming to this K2 protocol and then the tokens, if they're coming with their RETH or their STETH, because that's what they have, that's what's prevalent, and they want to convert it to this KE. Is any protocol taking a fee here, or is it really just, what the conversion rate from RETH and STETH to bring it into KE?
What do you mean by
Is that
protocol fee?
like is that something that the K2 will do for free for you?
Yeah, I mean,
Yeah.
there's no commission for KETH. It's
Right.
just a
Yeah.
smart contract. Maybe at some point that Ethereum will start like every smart contract operation has to be pay a commission. Then we'll think about it.
Got it.
Yeah, but maybe the dApp can actually show that we haven't shown the dApp, right? So if you come to the dApp, how do you deposit? Is that a question? Like if you have an ST or RE, you really have to get this key. It all happens automatically if you go to the dApp. Phil, do you have the dApp? Or Vincent, do you have?
You think, Phil?
You mean the Figma?
Well, the dApp might not be having the full features here. Cool. So,
Yeah.
we do have a dApp.
We definitely do.
Yeah, this is loading. Yeah, this is the Figma design for K2.
Prototype, right? But yeah.
Yeah. Yeah, this is a dashboard which will show the user's position. User position has, two kind of positions, like the liquidity position on the lender side and, borrow position on the borrow side. And there is another, on React tab. So this will show the lender's claimable amount here.
Mhm.
And he can, collect the claim and he can, something like that. Yeah, and this is the deposit, a lend page, so where the lenders can lend their keys, which means
No, is
oh,
that a
it is a borrow
it's a
page.
borrow page.
Yeah, this is lend page. Yeah, they can deposit keys, but user can select any LSC tokens, and this will directly deposit into keys and mint keys. Yeah, and create
So
the liquidity position.
if I have STETH, I'll just deposit STETH, right? It will automatically make KETH.
Yep.
But if you have KETH, you can
Yeah.
deposit it, no problem. If you have any of this listed representation of LSTs, you can simply deposit and then you're in, right? That's all you need to do.
So from a user standpoint, I'm coming in with STETH or RETETH, KETH, whatever it might be, and I'm putting it into this, getting this unified risk. And then people are, we're using like these borrowing and lending. What is my risk as a lender? Because it seems like a lot of it's kind of managed for the borrower takes on most of that slashing risk, but where does the risk come in for me as a lender, and what do I have to watch out for?
Opportunity risk. You're keeping your ETH at the pool, so you cannot use it for something else. But that's the reason that the pool is paying you based on the borrowing it has from the middleware. So if the borrowing goes down, then you have lesser yields. But that's basically the opportunity cost. Yeah.
Okay.
It's ETH, right? Essentially, it's ETH. Yeah. But then
But
now
yeah, the other thing is if the service providers are not lending, then you grow your case slowly, but fundamentally, yeah, apart from what Matt said, there's not really.
Yeah, you can withdraw it, right, anytime.
Yeah, and that's a point for the SPV positions. So pardon?
How to deposit and how to withdraw. There is no waiting period or something. Just go to that app and just click. You're done.
But if the lenders will pull their capital, right? People taking out debt positions can terminate it early on the basis of that, right? If there's no slashing security, you can recoup your funds, right? So it works on both sides. So lenders can get their money back early, and so can debtors, right? But the incentive of keeping your capital in K2 as a lender is that you're going to accrue more KEs. So that's why you want to stay there. Borrowers want it because they, as Matt was saying about the benefits for your protocol, and who knows in terms of the periphery, there's lots of things that we can build. Not us, but anyone can build. Additional incentives for K2 LPs. Maybe they offer their own tokens, and they're all kind of things that can be built around this.
Right. How does the termination look like? Do you have that? If you go to the borrow position, how does the borrow is actually?
Yeah. Here. So we have slightly different page for first borrow and increase debt position things. So at the first borrow, you need to input the borrow amount, design a verifier, and
this is first time that you're basically the middleware is first time registering, right? And then borrow amount.
Yeah.
Okay, cool.
And a borrow confirm. So I borrow the position. Oops. Yeah, this is another page for.
And if you're a middleware, you just want to terminate your thing with the K2, what do you do?
So we just have to terminate SVP button here.
Yeah, but there's an unpaid one, so you have to pay. You have to top up, right?
Yeah, this is the slash amount.
Yeah.
That should be paid. So if I click this one, and it will show, a transaction summary to repay the current debt. So currently, suppose the full repay. The slash amount.
That's the consumed debt from the pool. So you just pay them before you terminate. And
Yeah.
you confirm, then you just then you can terminate, right?
Yeah, so when it terminates, we check if the slash amount is 0.
Yeah.
So
And
yeah.
then you just terminate. It's another transaction.
Yeah,
So you just click off
it's
buttons.
not
Like
clickable.
anyone can basically do that in dApp. You don't really have to have much technical knowledge or anything. How this thing works, you don't really have to spend weeks to build your slashing logic. You don't really have to do anything. It's super plug and play. Thanks.
Maybe
Thanks.
we need to disable this terminate
Yeah.
button if
Yeah.
any slash amount.
Right. Cool. Thanks, Phil. Any question, guys?
No, so what's how do we explore the periphery then?
We can
Should I
talk about
share my screen?
Yeah, that would be great.
Right. Let me share my screen, Phil. Yeah.
So you can start.
Sorry, yeah.
Okay. Okay. All right. This is reporter stuff. So, but on the periphery, right? So, from a smart contract perspective, right? So it's very composable and plug and play. So, where can we go with this?
Let's talk about what's the LST our owners, the ST holder, RETH holder, how they are going to benefit from K2 protocol, right? So if you have let's take ST or RETH or whatever it is. You deposit to K2, you have ST, and you deposit to K2, you will get staking yield, right?
So
the first yield will be the staking yield, right? Each staking yield,
okay.
so you get it.
Okay, so we have LSTs including right.
Plus.
Okay. Yeah. Plus. Well, yeah. So okay, so we have the what is it? What is it? K depositor? Right. So we have that. So you bring your assets here. So wait, so user, so you're gonna be an LST user. Right. So you're going to bring your asset. That's going to lend KETH, right? So
Yeah.
Basically, so at the base, stake yield is being accrued.
Yeah.
Right.
So you have staking yield, some plus 4% in ETH, right?
So basically, okay, yeah. So you have Ethereum staking yield, 4+%. So it's worth stating that. So basically, KETH is so it's a staked unit with yield, right?
Yeah.
Okay.
Now you will get the K2 pool yield, right? Because the depositor, if you put the every LP holder will also get a pro rata share of whatever the K2 yield in ETH.
Okay, right, let me give this thing a bit more space here. I'll go back. Okay, sorry. Let's go through that again. So K2, right, okay. So we have
K2.
borrower. So
Yeah,
this
borrowers.
is a lender, right? The lender owns some
Those are restakers,
LSTs.
right? They're restaking their ETH, right? Those are
Right.
Yeah.
Okay, shall I call them restakers?
Yeah, let's see. What is this? Because their money is not going anywhere. Standard lending is you're giving your money to lend out your money to someone else. That's not happening here. You're restaking only for certain things, right? No one is taking your money away.
Right. So the assets are right. Okay. Right. So then we have borrowers. So borrowers, they hold KETH as well. So they holding so this year we have some, you know, KETH as well. So the borrowers are they are
Or one of these LSTs, they can either deposit STE and then it will convert into KE.
right. That's true. That's true. And the interest payment.
I think the yield actually goes from the K2 smart contracts because they're paying to the K2 and the K2 has more yield, not only from the borrowers, but sometimes it's, the termination fees, liquidation percentage. Whenever there's a reporting happens, sometimes half of it actually goes back to the K2 pool. The K2 pool has that business logic, right? And it has a yield. At any given point of time, you have a K2 yield for everyone can enjoy supplying that, the LSTs into that pool. Correct?
So this is the second yield tier, right? Do we calling it a yield tier or?
Yeah. That's a second yield. That's ETH yield. So you have two ETH yields now here: staking and restaking yield. Correct?
Yeah. Okay.
Now, what else you can get it?
So the restaker has deposited into K2, right? They've lent their LST. They got a KETH, right, which is then represented as a K2 LP position, right? And at the base, if nothing happened, if nobody borrowed, okay. So what we're saying here is if nobody took a borrowing position in the K2, you're earning yield on KETH itself.
Yeah.
Just by depositing in K2. So
yeah,
you don't have to have any demand for usage of K2 to be yielding at the Ethereum network rate, right? But if you do, if borrowers are opening a position, they'll make an interest payment to the K2's contract, and that will get streamed to the restaker. So that's your second yield tier, right? That's still ETH. That's still ETH.
Yeah. So that's a restaking yield. Now, can we have emissions like the people who are depositing, the borrowers can give their native token to the K2 pool, right? To incentivize the pool to have enough, because that's what I was asking, what's the cost? There's an opportunity, someone has to put like a lot of ETH there. So you can like give bribe or just drip. Let's say we are providing $1 million worth of that ETH security for us for a year. This is X amount of tokens will be just directly go to the K2, and it will go to the LP holders of the K2 from time to time. Yeah. Emissions, right? These are emissions, right? Could be. Yeah.
With K2 LP. With K2 LP tokens, right? So
yeah,
just a simple.
Yeah.
These guys will Okay, so that's tier 3 of yield.
That's the tier 3 of yield. Yeah, you're basically getting this additional tokens. It doesn't need to be, but they can incentivize, right? It's a market.
So I don't want to get ahead of you guys here, and maybe this isn't up for discussion, but is there anything stopping this restaker from also being a reporter?
No.
No, actually you're no, nothing stopping them. They can actually plug into this reporting and reporting Cascade lending, receive KETH. Yeah, so this, okay, let's assume this restaker is
So you basically run a software in your computer. That's it.
Yeah, so what I'm thinking is that this restaker, most of them will likely want to be this passive restaker, right? Where
Yeah.
they put in their K ETH and they get yield from tier one, tier two, tier three. That's why they're not actively doing the validation themselves. But there is a possibility that maybe this is somebody coming in through Stakehouse or something who's already actively running a validator. They already have a machine.
Anyone who has a
Anyone.
machine who can run a software.
Yeah. Yeah, exactly. It's already somebody with a machine who's running an ETH node, even though they don't have to run an ETH node, could also kind
It's a
of
simple software. You can run
quadruple
it on
it.
your mobile if you want.
Yeah.
Not a node. Node requires a huge machine, like comparatively for this.
Yeah.
Yeah. So this is like a super lightweight software. You can just run it in your laptop or somewhere.
Can I approve my stakeout slot?
You could, if it is approved. Yeah, you could. That's like a node runner. You don't really have to have, but you can actually put the DETH. But what you could do, you can actually have a not the slot, not. Oh, so that basically like any existing node runner who has a validator, who doesn't really have to have DETH, but you have a validator, right? You're a solo staker, whatever you are, right? You can simply go and register with the stakehouse before you stake. So you have your validator in the smart contract. And then you restake and you get this knot, which is the tokenized position, right? And the knot, so it's just like couple clicks is important. That's nothing. It's just, and you have a knot. Now you can approve a knot and then you can restake that into K2. I mean, it's totally possible because now you have a debt position as a knot. The K2 smart contract can reconcile how much ETH is there for that validator, right? And if it comes back from consensus layer, if you haven't, you're not losing any money here because you're basically giving to K2, and the K2 has given. K2 will get repaid back from the middlewares, right? So you just get the yield, and it will go to your not address, right? Not address will have an ECDSA, right? You're a node address. So if you register that, you have yeah, it will be given.
Right. So
I mean, it's natively like you're just basically signaling, I'm also joining the restaking market. They don't really have to bring any kind of, if you're a solo staker, if you're a node runner, if you could just can make sure you have your validators are tracked on a smart contract, which is the easiest way you can do it is like just register with the stakehouse before you stake, and then do another transaction and get the state back. That's all you gotta do. You don't really have any kind of liquid position, tokens, doesn't matter. You can do that. You're a, I don't know, light operator or rocket pool operator or any solo staker, whoever wants to. Nothing stopping you do that.
right, I'm trying to look for more tiers of yield. I'm sure somebody with a DGM mindset's gonna put. Let's see. I'm not saying anything.
So now you are a reporter. A reporter also get you run a software. You get ETH as a reporter, right? Whenever you're reporting that, so you get that the third. You have three types of ETH yield. First is the
I've got
staking
4.
yield.
Yeah.
No, ETH yield. ETH yield.
Oh,
You
okay,
have,
okay.
you have staking yield, native vanilla staking yield. You have restaking yield, which is coming from the K2. If you're running a reporter software, you get this kind of reporting. Anytime that you report, you get ETH for that. So you get that ETH. So that's the third ETH tier. But then you have emissions in the native ERC20 tokens that is the middlewares are giving. But what if you are an LST network and who want to incentivize for restaking? So LST networks have their own, the staking yield is there. But if they're saying like, our depositors can, deposit into K2 pool, and we will encourage that, if you deposit more into K2, they're capturing LST or LST networks. Both if you're running a liquid staking networks too, like any new liquid staking networks we want to launch, right? regardless how you do it. And if you're part of a K2, KE, the listed tokens, you can incentivize your tokens to come into the K2 pool because it will help your users to capture additional ETH yield, all the ETH yield that we are saying here, that being an LP holder, you can also approve some emissions, right, in your native token. For example, if RPL tokens can be, RETH can be deposited as much as there, and RPL can also be provisioned there if you want to get more and more yield for your native token holders. Because it is approved for the restaking.
So there's so many different types of yield available to the restaker, and there's so many variables on how people want to kind of utilize this. I'm really curious what the final yield is going to be, kind of in its prime form. I know we can kind of estimate the first tier, at that 4%. If we want to move into, the second tier, that can maybe start to be estimated as well. But once we get into the third and fourth and extraneous tiers, it's like this. I'm not sure where this can go, but I'm really curious to see where the yield can get to.
If you do a napkin math, like 4% on the staking E, the pool, the K2 pool can give like 6 or 7% easily if there's borrowing. Because all the usage fee actually goes to the K2 pool holders, right?
It's utilization based. The more utilization, the higher interest, and the higher the riskier positions will mean large interest payments from the borrowers.
Right.
Some things are.
You're talking about 10%, in and around 10%, without considering the reporter payment.
So that's two. So that's the first two tiers that we're looking at about 10, 12%.
Yeah. And then if you're running a reporter, it just depends on how many services that you want to report and get that. That's a variable. That's kind of an MEV kind of stuff, right? You don't know. You're not sure about the yield, but you may end up like capturing about 5% if you really run multiple reporters for multiple services. So if you're a reporter, you can actually run reporting for all of the middlewares that's there, right? Instances. So you can capture, maybe you're too lucky, some of the events has been captured, has been gone through. Maybe you get 10% or 15%. I don't know. Maybe you get 1%, right? You never, report it.
Yeah, but it's still one. I mean, I guess like it's hard to put a percentage on the reporter, but even if somebody, okay, if you're just running this software, the reporter doesn't necessarily need to have ETH at risk. But I guess with the restaker, even if they just put in one ETH, they're getting 10, 12% off that, and then if they're able to earn, even just get a few reports a year, depending what they are, that could be quite large. Like you said, it's like MEV. It's hard to estimate how large some of these can be.
I don't know. It really depends on how much market wants ETH as a security.
Right.
Do you really believe that ETH is a high demand asset? Then then there is a yield. There's an opportunity here. The economic security and the trust is really composable here. So they can go. It really also depends on what the middlewares and other kind of smart contract protocols or Web2 protocols who want to use this readily available economic security for going the logics that we mentioned, right? How they want to use it for. Because if they borrow 100,000, if there is a protocol that says that, I mean, we are reinforced by 100,000 ETH a year security, that will actually give confidence to get $1 million or $2 million worth of the TVL or something like that, because that gives a confidence to the market because the protocol has been reinforced with the restake ETH, right? If something happens, and it's completely verifiable, so it's sort of a positive sum. It's not about the yield; it's about the value accrual through the decentralized systems, and they can immediately launch their service without spending a lot of money. So their cost to this is super minimal. And they can attract a lot of other kind of use cases, which in the normal case will take a lot of time and effort and money. And this is faster, cheaper, better, all three included, right?
or without having any knowledge, without having any kind of technical debt, plug and play. Come and click, 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 you good to go and readily available. Make sense?
No additional blockchains needed.
No, no. Oh, that's a cool thing. So you can actually report any kind of data, regardless, any kind of curve. There is no limitations, right? What kind of data that you want to report?
We support BN. Yeah, we support 128 Ethereum, but we also what is it called? Edward. Yeah.
Yeah, we have Edward curve too. So Near, Solana, Polkadot, you name it, Cosmos, any kind of things. Like if you're there in the blockchain, you can just use it. You can run a DA. If you are a DA services, you can actually use this just to onboarding services to your DA, and then the payment module is here, right?
And people will report the liveness of your DA, right? Liveness is really critical for a DA. So is corruption, actually.
Yeah. If you like in a Celestia or any kind of data layer, or even you're running like in a kind of bundlers and things like that, you can just use this. So the payment modules is built in, so you can just use these contracts. And you only need to write maybe a few lines of code, just call the contracts and just make the decisions. So yeah, that makes sense, Derek, from a commercial standpoint. Like just trying to explain how this could be used. It's really up to the developer.
Yeah, I think it's really up to the person and the protocol. And what I really like about this is there's so many different opportunities for people to get involved. Just somebody can come in with just ETH, they can stake it and get this yield. If somebody wants a little bit more, they can come in as a reporter, download and run a simple software. But then when it comes to the actual middleware itself, it can be applied, really anywhere to any Web 2, Web 3 sort of blockchain. And I think it's really interesting that you mentioned this whole idea of a DA and being able to verify data, because that seems like such a nice fit here. Like this protocol K2 is so lightweight that it can be utilized with the DA without a huge lift. It's kind of a plug and play thing.
Yeah, you could have multiple DAs on top of this, like as well. You can have multiple blockchains, you can have multiple rollups, you can have multiple services, you can have multiple protocols. It's just really like you can expand anywhere that you want. But let me ask you this: if I have a K2, I'm a K2 LP holder, and I have a farming contract, I can accept K2 LP tokens because these are standard LP tokens, right?
Standard ERC20.
So the K2 LP token have natively, I'm saying that an average of 10 to 12% ETH plus all the emissions. So if you're farming your LP tokens into a farm contract, you're basically talking about 10 plus maybe all these other emissions, 25%, but different tokens. But that's a very interesting asset that you want to have a farming, like money, or I don't know, whatever the other kind of farming.
Yeah, interesting. Because even at the base level, because it is, a basic LP token, somebody could take it to, a beefy or some sort of auto farm thing where they can plug it in. And at the base level, it could just keep restaking keep staking all their rewards as they're getting them. Now, a kind of interesting point that you're saying too, where I know people are starting to do some really interesting things with these LP positions. And I'd be really curious to see what people can build out of this, especially when it is sort of a one-sided LP token rather than the two-sided.
Yeah. I mean, it's totally possible. No one can stop it because it's just smart contracts. You can do it whatever you want. Immutable contracts. Yeah. That's very interesting.
Gives a new meaning to rollups as a service. I mean, I'm going to stop.
No, the rollups needs it, right? So think about this. Every rollups have this kind of a, they need to put their proof back into the chain, right? From time to time, so the Merkle tree. So you have this kind of a sequencer, right? Shared sequences, right? And then the proposer, so now you need to have lock space for everyone, but shared sequencers say that, I'm going to put some sort of every time this rollup state root will get injected. That, and then the rollup number 2, the rollup number 3, the rollup number 4, because that's the shared sequencer will just they provide this kind of data availability, but they also extending their state root will be injected to Ethereum because the rollups has to go. And if there is any kind of problems with the state root updation, just get some restaking thing. You don't really have to go through anywhere. Just make sure when you spin up a rollup with the Contude or the other kind of like the rollup frameworks that you can spin it up with an OP-Sec within 30 minutes, get some restaking for your rollup. So people who are bridging asset to there, the protocols are deploying there, there's some confidence your state root is actually getting reported back in time to time.
So we can decentralize the sequences then?
Yeah, totally, yeah. Anything. So if the sequencers have some sort of a time-based event, right? So anything required timely reporting that can be reported.
Yeah, I mean, like fraud proofs are notoriously very challenging things, but you can build fraud proof with K2.
Yeah, you could even have like asset bridgings, and that is also correct. Endorsement or liveness and corruptions. It basically tells everything, and you can just inject the business logic in a way that you want to use it for to show the work is done, or maybe you can compose couple of events into one thing. Like if I have X and Y, then Z can happen, right? It's like kind of a do calculus. So if you have like certain things have happened, then you can open a the smart contracts are notoriously like it's automated, but it's not automated. So it's very it's automated in a sense that it will do what it is supposed to do in an
when it
execution
gets
layer.
poked.
Yeah, but you need to poke it. So you can actually build this kind of minion robots, and the smart contracts will do it. If you want to have a onboard like real world assets, if something happened there, click it's just report, and it will trigger a smart contract operation, and it just goes through. And everything is like poking data, but it comes down to one thing: data integrity, right? Once you have a tamper-proof data integrity between the exchanges, you can build any kind of logic, and that's why we made sure this is the ZK technology that is programmable to an extent that whatever you want to program on top of it.
Yeah, I think that's kind of a good point. It's very interesting because a lot of, what this can do is add to, smart contracts and to different protocols and even sort of Web 2 and Web 3, this sort of operational security, this ongoing security that people can do and just like ensure the data ongoing and kind of make sure that the core information that's coming through is accurate and presented in a way that is intended by the protocol or application.
Yeah, and you don't have to pay anyone else.
Yeah.
Any questions from your side, Derek?
I think we covered quite a bit. Yeah.
Any other question, guys?
Watch this space. I'm sure we're going to do more content.
Cool.
Yeah.
And that's a wrap. It's okay too. Thank you.
Right.
Thanks, guys.
Thanks, guys.